Alright, I'm going to talk about binary numbers now. So, binary numbers are similar to our normal number system, which is a decimal. We think of numbers as starting at maybe 0, and you go to 1, 2, 3, 4, 5, 6, 7, 8, 9. And then after 9, you run into a problem. You've used all 10 of our numbers, or digits, so we have to combine digits. So we go to 1, 0, or 10. Binary is similar. You start with 0, you go to 1, but then you run out of your two numbers. Your 0 and your 1 are both used. So you have to go to the same thing, 10. After 10, you go to 11. And then you run out of those. You have to start, go to the next spot, and you have 100. Then you do 101 and 110, 111. So you can see how the numbers go up. 0, 1, 10, 11, 100, 101, 110, 111. So the next number would obviously be 1,000. So that's how it works. So we have each digit in your binary number has a place value. So if I have an 8-digit binary number, let's say it's 1 0 1 0 1 0 1 0, then the first digit on the right hand side, this is the ones digit. The next one right next to it is the twos digit, or the twos value, and the next one is the 4, then 8, then 16, 32, 64, and 128. So if I wanted to figure out what this number was, well, I can say, well, there's no 1, there's a 2, so it's 2 plus, there's an 8 here, 8 plus, there's a 32, and there's also a 128. So if I wanted to convert this to what its value is, well, you can say, well, 128 plus 32 is 160, plus 8 is 168, plus 2 is 170. So this would equal 170, I believe. So you can see how you could do it. So let's pick another number so we can see how they look. Let's pick the number 11001101. Alright, so now we have a 1, and we have, there's no 2, but there's a 4, and there's an 8, and there's no 16, no 32, there's a 64, and there's a 128. So we look at this and we say, well, 128 plus 64 just happens to be 192. 192 plus 8 is 200. And then there's 4 more, 204, and then 1, 205. So this would be 205. Some common numbers you'll see in doing binary are the numbers 0 0 0 0 0 0 0 0, which just happens to be equal to 0. There's also 1 1 1 1 1 1 1 1, which is equal to 255. These ones appear a lot in networking. Some other things you'll see a lot is combinations of ones. So let's start with the right side. Let's say you have 1 1 1 1 and a bunch of zeros. So the question is, what does this equal? Well, for this, let's look at decimal numbers, for example. if we had 999 and we added 1 to it, that would be equal to 1,000. So 999 plus 1 is 1,000. So if it was 9999, we know it's 999. In binary, it's similar. We have a 1, 1, 1, 1. If we added 1 to it, then we would get the next number, which is 1, 0, 0, 0, 0. And we know that the first one on the right hand side is a 1, then there's a 2, 4, 6, and then we have an 1, 2, 4, 8, and 16. So this is 16 right here. We can subtract 1, and we can find out this top number, the 4 ones, is 15. So that helps us. Whenever we see a series of 1s, we can easily calculate it out. So let's try one more, just so we can see how that works. Let's make 6 ones. 1, 2, 3, 4, 5, 6, and then 2 zeros. So what would this be equal to? Well, we don't know immediately, but we do know this is the 1, this is the 2, this is the 4, this is the 8, 16, and 32. So our immediate guess is it's going to be 1 less than 64. So 64 minus 1, which is 63. Now we could verify that by saying, okay, well, if we added 1 to 63, we should get 64. So we add 1 here, and we get now 0, 1, 0, 0, 0, 0, 0, 0, which I'm going to do 128, 64, 32, 16, 8, 4, 2, and 1. So we know this is 64. So we know that this top number must have been 63, because if we add 1, it gets you 64. So this is how binary works, and it gives you an idea of how to do some basic mathematical calculations there.